as this comes up, that'll be my first question. Do you have any questions? So here we go. Any questions? Anything we've covered so far? All right. If not, we I think it covered this slide last time, right? Two things that we watch out for in the domain of a function, an implicit domain. Anytime you have a variable in the denominator, you've got to make sure that variable cannot make that denominator 0. Get your name, please. Second. Carter. Okay. Cammy. All right. Good deal. So the first is anytime you see a variable in the denominator, red flags, check and see if there's any way that variable can make that denominator 0. If so, you have to exclude those. The other is if you have a square root. Okay, now it has to be a square root or a fourth root or a sixth root, any even root. Odd roots, no problem. But even roots, the thing inside, if the variable is inside that, whatever is inside the radical cannot be negative. Okay? It has to be greater than or equal to 0. Okay? So I think we're ready for example 7. Find the domain of these functions. Let's do the first one, f. What is the domain of that function? Let me get my pen set up. The domain of f. It's going to be a set. What's it the set of? The domain of that function f. -3. Okay, let me get your name, please.
Yes.
Okay. Josh Jackson, got it. All right. Anyone else whose name I didn't catch? Snuck in while I wasn't looking. Okay. Whoa. Don't do that. Yeah. If this thing can get tangled up, it will. Okay. There's one member of the domain of f. Are there any others? -1, 0, 2, and 4. Okay? Now, just looking at those domain elements, I can tell right now this has to be a function. Okay? Because none of these are repeated. If any of those were repeated, I'd have to check and see if the second element was repeated. If it was, that's okay too. But if it was not, a different second element, not a function. So that one's okay. How about G? What do we do about G? What do we know can or cannot happen with G? Second? You may have said it right. I just don't hear well. Let's say? Second? Set it, okay, let's set the denominator equal to 0. Actually, I like to do it not equal to 0 because it can't be 0. So, book does it the other way. So, either way you want to do it. X plus 5 cannot equal 0. Okay, you can never divide by 0. And if you solve that inequality, what do you get? Okay, X cannot equal -5. Okay, so what's the domain of the function? A couple ways you could express it. Okay, you could write it out there. All real numbers except -5. A little bit shorter way of doing that would be in set notation. Set of all real numbers x such that x is not equal to -5. That says the same thing without having to write all those words. Is it Amber? No, I'm sorry. Okay, got it. Thank you. Couldn't see. Yeah. Okay. Good deal. All right. Can you think of another way to express that domain? Interval notation. Okay, how? How would it begin? Open parentheses, negative infinity to -5. Parentheses, because it cannot equal -5. So you have to have a parentheses there. Then what? union, parentheses, -5 to positive infinity, close parentheses. Perfect. Way to go. Okay? Everything except -5. And here's Tyler, right? We hunt. Okay. All right. How about number C? Letter C. The volume of a sphere is V is equal to 4/3 pi r cubed. That's a formula of nature. Volume of a sphere. What is the domain of that function? Can you see it? Okay. I wish I could get pulled back some, but I get trapped. Okay. What would be the domain? Second? 3. Okay. I think you can do probably more than 3. What is the independent variable? Second? No, pi is a number, just like 4/3 is a number, only it's a different number. R is the independent variable. So when we're looking for domain, all the possible values that R can take on, what would they be? Second? Anything, okay? You're saying all real numbers.
So you would put that under 1, put 1 over,
1 over what? Okay. No, you may be right. Okay. Now, you said any real number. Is -3 a real number? Okay, I want you to draw me a sphere with a radius of -3. Please, come up here and do so. I'd love to see it. I've never seen one in my life. What's wrong with that picture that we can't see? You can't have a negative radius, can you? I've never seen one, okay? And that would give us a negative volume. Oh, okay, we'll sink, you know, there's nothing there and it's sucking everything in. A black hole, okay. Nah, that won't work. What would be your possible? All positive numbers. Not even zeros. 0, a radius of 0, you don't have a volume, do you? Okay? Because you have no radius. There's nothing there. Okay? So this will be, give me a couple ways to express that. Set notation. This is the domain of V, of R, is the set of all R's such that R is greater than 0. Perfect. Now in interval notation, what would that be? I'm sorry? You say it can't be a fraction? A bracket. Okay, where? Okay, no, we don't have 1. We have a 0 there. Say again? Okay, except I thought you just told, can I get your name? Amari, got it. Okay. Okay, good deal. Shaping up to a good class today. Okay, say again what you were saying. Bracket with the 0?
it's in the second.
The second one. Okay, the second example. Are you wanting to change that? Is that what you're saying?
No, you said it was the other form with the right. I was saying with the second form, would it be bracket?
Would it be a bracket? Is that what you're saying? The second one, the second form here.
You said the second way to write.
Yes, okay, the interval notation. Okay, you say a bracket. Okay, what does a bracket tell you?
The bracket shows that it can be.
Can be, and so what goes out to the bracket?
R.
No, not R. R is right there. Say again? Okay, you say 0. Now, I want you to come draw me a sphere with radius 0. Okay, yeah, it's going to positive infinity. I'll buy that one, okay? And that's closed by parentheses. but I want someone to draw me a sphere of radius 0 up here. Oh, you already have. It's just not here. There isn't one. So what does that mean? Can't be 0. And how do we designate that? Say again? A parentheses 0, because it cannot be 0. Okay? Very good. All right. How about D? What's the issue there? Is there an issue there? You won't have to draw anything on this one, I promise, okay? Don't even make a guess. Say again? Okay, no, minus signs are fine. Yeah. Say again? You've got to have a positive number, is that what you're saying? You can't? Oh. You can't have a negative where? In the radical. Okay, hold on just a second. Get your name, please. Raquel. I can't hear, sorry. Raquel, got it. Okay. Got it. Okay. So, I think I finally heard that what's in the radical cannot be negative. Okay, that's a lot of words there, and we still don't know what the x has to be, so how do I express that mathematically? What is in the radical? 4 minus 3x. And how can I express cannot be negative mathematically? Yeah, I could write all that out if I was that active, but I'm lazy. Aha, very good. Greater than or equal to 0. There we have it. That means it can't be negative. If it's got to be greater than or equal to 0, it cannot be negative. Real shorthand, right? Now we have to solve that inequality. So what do we do? Say again? Okay, I can't hear. Yeah, how do we solve it? Subtract 4 from both sides of the... Okay, I'll buy that. Minus 4 from both... subtract 4 from both sides. The left-hand side becomes negative 3x is greater than or equal to negative 4. Okay, got it? What's next? Okay, divide by negative 3. And what does that give me? Negative 3's go away. Hey, someone caught right on here. Less than or equal to 4/3. Okay. Why did that change? It was greater than or equal to. Because when you multiply or divide by a negative number, which we divided by a negative number, you have to flip the direction of a directional inequality. You can add or subtract, positive or negative, doesn't change the inequality at all. You can multiply or divide by positive numbers, doesn't change the inequality at all. But if you multiply or divide by a negative number, you've got to flip the inequality. And you did it absolutely right. Okay? So, x has to be less than or equal to 4/3. So you can write this in set notation as the set of all x's such that x is less than or equal to 4/3. Okay, that's one way to write it. What's the other way? Second? Parentheses. Okay, yeah, we'll start with the parentheses. Negative infinity, that's certainly less than 4/3. Okay? Going up to 4/3. Bracket, you finally get to use your bracket. Okay? And there it is. Okay? The reason it's a bracket, you include the 4/3. The equal sign is here, so you put a bracket there. Perfect. Y'all are good at this. Any questions? Does everybody see why that's true? You cannot take the square root of a negative number, so therefore this thing in here has to be greater than or equal to 0. You cannot divide by 0, so that denominator cannot equal 0. You just put down what you know, okay? Good deal. Let's see how the book did it, okay? Let me just check before I erase. Page 40, section, chapter 1, functions of the graphs, 1.4 functions, and this is example 7 on page 40. Okay, I think the book did all right. Okay, so we will move on from here. Okay, I think, yes. Domain of the first one, remember, was just the first element in every ordered pair. -3, -1, 0, 2, 4. Y'all were perfect on that. The second one, letter B, excluding values that yield 0 in the denominator meant that the domain of G was a set of all real numbers except x, except x equal -5. They wrote it out in sentence form perfectly fine. You can do that too. I'm just way too lazy to do that. Okay? I put set of all x's such that x is not equal to -5. Okay? And C, because this function represents a physical entity, the volume of a sphere. The values of the radius have to be positive. You can't have a 0 radius, you have no sphere, or a negative radius. I don't know what that is, okay? So therefore, R has to be greater than or equal to 0. So the domain of the set of all real numbers are such that R is not greater than or equal to, greater than 0. And they wrote it out in a sentence, way too much work for me, okay? And then that last one, the function is defined only for values for which that thing inside the radical has to be positive. Well, non-negative. It can be 0 or positive. So that says it right there, greater than or equal to 0. And then solve the inequality, and you get x is, they don't show you how to solve the inequality, but solving it, you get x less than or equal to 4/3. Okay, so then they wrote that one in, that was in a sentence. This one is, name please? Decline, right, thank you. I know you're in here. There you are. All right, anyone else come in since I called roll? Didn't hear me call your name. Okay. So the domain is from negative infinity, of course that's not a number, so it's always preceded by a negative, by parentheses, up to, but including the 4/3, so we put a bracket. Perfect. Any questions? Okay. We're on in chapter 1, functions of the graphs, 1.4 section, functions, page 40, example 7. We just finished it. And guess what follows example 7? A checkpoint. And checkpoints are great things to do as soon as you can once class is over with, to review, refresh, reinforce what we've learned in here. Now, in example 7c, note that the domain of a function may be implied by the physical context. It had nothing to do with the mathematical. Let me go back here just a moment, okay? They were going to say it there. If they had said V is equal to 4/3 pi r squared, pi r cubed, without saying that's the volume of the sphere, even though you know that's the formula for it, if that was just a mathematical equation, you can put all real numbers, what you just said earlier. Any real numbers will work there. But if you know it's the volume of the sphere, no, negative radii don't work, and negative volumes don't work. So the physical context is also an implied domain, okay, and that's what they're getting at here. Note that the domain of a function may be implied by the physical context. They said that was it. If they had just said that, you have no reason to restrict it to positive values. The physical context implies And they said, volume of a sphere. As soon as they said that, you can't include a 0 or a negative radius. Okay? So, any questions? Now, applications. Here we have one. You work in the marketing department of a soft drink company, and you're experimenting with a new can for iced tea that is slightly narrower but taller than the standard can. For your experimental can, they just give you this, the ratio of the height to the radius is 4. Okay? Now, as soon as they say that, I want to write it down. But I want to write it down in math speak. Okay? What do we mean by ratio? Anyone? A ratio. Not difference. Okay? Difference would be a subtraction. What is a ratio? Say again? How they relate to each other? In what sense? In what mathematical operational sense? Not subtraction. Division. Perfect. Okay, so the ratio of the height to the radius, that would be h divided by r. If you let height be h and radius be r. Is, how do you translate that? Is equal, and then you're right, for, you can put it over 1 if you want to. It's perfectly fine. Nothing wrong with doing that. Okay? What happened there? I don't know. Okay. So as soon as you see a sentence like this, translate it to a math sentence. The ratio, meaning division, of height to radius, height divided by radius, is equal to either 4 or 4 over 1. Either one is fine. All right. We got that then. Now, write the volume of the can as a function of the radius r. Okay? What is the volume of a... Okay, now, we're going to make some assumptions here. And I think they've indicated enough that we can tell. Number one, they said the radius. So that implies the can is the imprint of the can is a circle. Okay, so it's a circle, and we call that a right circular cylinder. Right meaning it's a right angle with the ground here. In other words, it's not a tilted can. That would be rather weird, okay? So it's a right circular cylinder. So we need to know the volume of a right circular cylinder. Does anyone happen to know that volume? If you don't, and you do have a book, I just lost my page. If you go to the back inside cover of the book, you'll see formulas from geometry. On the right-hand side, third from the bottom, right circular cylinder. But you know you don't need to do that, because we can figure that out, can't we? Sure we can. We just said it's a circle at the bottom, so the volume of any regular shape, volume is equal to the area of the base, we put capital B when we mean area of the base, times the height. That works for just about any regular shape. Okay? Well, what is the area of the base? What's the area of a circle? We said the base was a circle. Pi. What'd you say? R squared. Now, I always thought pi were round, but no, you said pi r squared. Okay, never mind. Okay? And then multiply that by the height. There's the volume of a right circular cylinder. You can check in the back to see if they got it right, but they did, I think. Okay? There's a volume of a right circular cylinder. But this is a function of both radius and height. We want it just as a function of the radius. So that means we need to get rid of the h. And that doesn't mean erase it. You can't do that. Can's got to have a height. But this tells us what that is. So if we can figure out what h is from this ratio, then we can plug that in and we'll get everything in terms of R. So what could we do to solve this for H?
So you plug in the 1 for R.
Okay, let's not plug in. Let's, say again? What'd you say? Multiply both sides of the equation by R, right? You see, we really don't need the 1 there. Here, the R's go away, you know? Yeah. And you have H is equal to 4R. You see that? You could put 4 over 1 still, but it's not giving you much. It's 4R. Now, you come up here to this volume formula, pi r squared H, and you got pi r squared, and the H is 4R. Okay, now you can manipulate that a little bit. I'm running out of room. Let's bring the 4 out front, so that would be equal to 4 pi r cubed. There we have it. There is the volume of that can as a function of r alone. You might say, hey, wait, it's a function of pi too, isn't it? No, pi is a constant, just like 4 is a constant, okay? The only variable here is r. There is the volume of the can as a function of radius alone. Do you see that? Or any questions? All right. No questions? Now let's do the B part. Write the volume of the can. I'm going to write it down again. V is equal to pi r squared H. Okay? But this time we want it as a function of H, not of R. So what might we have to do? Let's go back to this one since it's almost there. If we can get R as a function of H, we can plug that in. We'll have our volume as a function of H. And how can we get R as a function of H? Solve for R. Divide by 4. Look at that. Now the 4's go out. They've been dating. Okay, so this gives us R is equal to H over 4. That also comes from our ratio. We could have gone back to do that, but we just had it almost set up for us there. Now we plug that in for your R. So this is equal to pi, and that R is now H over 4, but you're going to square that and then multiply it by H. You see that? Y'all have trouble seeing, don't you? Sorry. Do you see that? Make sense? I wish I could do something with this thing, but you know, I don't want to lose any students, but we're down to 3. If we get less than 30 students, or 30 students or less, we can fit back in that classroom. But, 255, but it looks like we may still be more than 30. I don't want to lose anybody, but if we do lose some people, we might be able to go back, and then I think everybody will be able to see a little better. Because this is a low board, narrow room, long way away back there. Okay, so, and this thing is in the way. Okay, so what's our next step? Let's bring all the constants out together. Pi over 4, and then times. Oh, not that pi over 4, is it? What did I forget to do? Let me go back and do it. Okay, let's not do that yet. We need to, please excuse, we need to raise that power. This will be pi. H over 4 squared will be H squared over 16 times H. Now we can combine the constants. That's pi 16ths times what's left? to the third power. Perfect. There's the volume as a function of h alone. So here's the volume as a function of r alone. Here's the volume somewhere down there as a function of h alone. Okay? The key is, whatever you're trying to get the function of, what you want to be the independent variable, get the other variable, h in this case, in terms of that r. Or get the r in terms of the h. You need it in terms of the variable you're going for, so that when you plug it in, you lose the h up here, you lose the r down here. So you solve for the h, solve for the r. Make sense? All right. Any questions? Okay. Let's see how they did it. Well, they came up with the volume as a function. It's not as a function of r, it's a function of r and h. Okay? Pi r squared h. What we're wanting to do is get it as a function of r. Well, from our ratio that we knew, we know that h over r is equal to 4, so therefore h is equal to 4r. Once we know that, plug that in, and then gather the constants together, 4 times r, and 4 times pi, and then your r squared times r is r cubed. Okay? The b part, we started off, but now we're wanting to get it as a function of h. That's still a function of r and h. So we want the r as a function of h, and that's going to be h over 4, which we also got from our ratio, but you're squaring that, so that comes out pi, and they wrote it differently than I did, but it's perfectly fine, pi h cubed over 16. Now, this is sort of an example of why I don't particularly care for WebAssign. And by the way, I'm supposed to have those codes, and I'm going to try to find them. He said he was going to send them to me, but I haven't found them yet. But I've had very little time to go through the emails because the emails just proliferate. But I'm going to try to, after this class, I have a little bit of office hours. I'm going to try to find that, and I'll put it out there on Blackboard. I'll send a notice, announcement in Blackboard, and also it'll send you an email automatically, okay, as soon as I can get the code. But here's why I don't make assignments in WebAssign. Because if that's the answer they were looking for, but you wrote the answer as I did, as v of h is equal to pi 16ths h cubed, guess what WebAssign would say? Wrong answer. And it's not a wrong answer. It's just not in the form they want it, but they didn't specify a form. That form is no better. I think is actually a little worse than this one, because this puts your constants together and your variables together. That mixes them up. But WebAssign, hate to say this for you people who love computers and things like this, but computers are really stupid. They only do what you tell them to. And if you only program in, there's one answer, then it says everything else is wrong, even though that's perfectly correct. In fact, I think better. But, no judgment here. Both of them are correct answers. But WebAssign would say wrong. And you say, what did I do wrong? You go back and pull your hair out. Oh, see, I've done it. No, never mind. And try to find where you made your mistake. You made no mistakes, okay? So it adds just a level of frustration I don't think you need. So that's why I don't make assignments. But please use WebAssign. They have good tutorials and illustrations and stuff. When you get it, feel free to use it to your heart's content, but don't get frustrated with it. If it gives you, of course, you have no way of knowing whether it's saying a right answer is wrong. But guess what? You can do the checkpoint, like follows this example, and then go to larsonprecalculus.com, and they have a audio-video solution, and you can see why. And say, oh, okay, my answer was just as good. We did all the same steps. It came out just the same. Okay? Good deal. Any questions? They're skipping examples 9 and 10, so let's us go back and do 9, and 10. Let me erase this ink from the slide. Okay. And let's do example 9. The path of a baseball. Any baseball players in here? Okay. Last time I taught this course, I had 5 baseball players in here. Okay. Huh? Okay. A batter hits a baseball at a point 3 feet above the ground. Now, I draw really lousily, but I'm going to try to draw this. So here's the batter, okay, and he has the bat in the hand here, okay. Yeah, y'all are making fun of me already, I can tell. Okay, and he swings and hits the ball right around 3 feet above the ground, okay. That's just about waist level, right? Sweet spot, okay. So he's hit the ball at 3 feet above the ground, okay? At a velocity, v is equal to 100 feet per second, okay? At an angle of 45 degrees from the horizontal. The path of the baseball is given by f of x is equal to minus 0.0032 x squared plus x plus 3. Okay? Now, what in the world is that? Where f of x is the height of the baseball. I would have called that h of x, but they called it f, that's fine. In feet, and x is the horizontal distance from home plate. I abbreviate like crazy. Okay. Now, the question is, will the baseball clear a 10-foot fence? No, it won't clear a 100-foot fence. A 10-foot fence 300 feet away. Now, I have to adjust my scale here. So this is going to be 300 feet away. And here's the fence that's about 10 feet tall. Okay? Will it clear? Is it a home run? For me, it might be a long foul ball, but never mind. Okay. Because my name is Fowler. Never mind. That has nothing to do with the problem. Okay. So, here's the issue. Now, does this equation, and you don't need to know where the equation comes from, but I will give you a few hints. Okay? And without getting into any detail, if you were to square 100, you get 10,000, but if you put that in the denominator, that's 1 over 10,000, and that would account for moving this decimal place 4 places here. You don't need to know why, okay? This is the velocity in feet per second. This is height in feet. So the acceleration due to gravity, which is the only thing pulling that ball back to Earth. Otherwise, it's heading into space, right? But because of acceleration due to gravity, pulling the ball downward is, guess what, in the U.S. customary system? 32 feet per second squared. There's your 3, 2. Okay. Now, what would normally go here would be our velocity, but remember we sort of divided by that, and divided by the square of that here, so you don't have the 100 here, you just have coefficient 1. But when you're 0 distance from home plate, when your x is 0, that's 0, that's 0, what's the height of the ball? 3 feet. That's where you hit it, right? That's making sense, sort of, right? Okay, so this is the flight of the ball, the height of the ball as a function of the distance. Okay? Well, what do they give you? They say how far the fence is, 300 feet. And they give the height of the fence, 10 feet. So all you do is, what do you do with Glade? Plug it in, right? So plug in the distance from, horizontal distance from home plate, 300 feet. Whoa, that's going to be a big number, isn't it? So F of 300, that's going to be the distance from home plate. I'm going to leave off the units now. They just sort of clog up matters. That's equal to minus 0.0032 times, what goes next? 300 squared plus 300 plus 3. I don't leave off your plus 3 there. Okay? Now, what are we going to do first here? Yeah, you got to exponent first. Minus 0.0032. And what's 300 squared?
900.
Not 900. You double the number of zeros. That's 1, 2, 3, 4 zeros. 90,000. Get out of there. Okay? Plus 300. Plus 3. Okay? Now, here's the easy way to deal with those numbers there. Let's divide this number by 10,000 and multiply that one by 10,000. Okay, we just moved this decimal four places to the left, that place 4 places to the right, and you got 9 times 0.32, no, 9 times 32. But that's a minus. So someone do that. I think we can do that in our head. That would be 18. That would be 28. Minus 288 plus 300 plus 3.
15.
That would be 15. 15 feet. Does it clear the fence?
Yes.
Yes, by 5 feet. In fact, not even a center fielder jumping up there with all he can. If he can go 15 feet up, he should be playing basketball, not baseball, okay? I don't think he'll make it, okay? So, yes, it does clear the fence. Make sense? All right. There is a checkpoint, too. Be sure you do the checkpoints as soon as you can after class. And you can always find the answers, worked out solutions, at larsonprecalculus.com. Any questions? Do you need that any longer? Okay. Now, this next one's sort of a pain in the neck. But we don't have it on the slide set, so let's erase all this. All right for me to erase? Everybody's got it? Anyone still writing? I'll be glad to wait. Everybody got it? All right. This time, the number S of fuel stations, I guess it stands for stations, that sold E85. Anyone know what that is? Second? Yeah, it's ethanol. It's 85% gasoline, 15% ethanol. E85 is a gasoline ethanol blend. It's 85% gas, 15% ethanol. In the United States, increased in a linear pattern from 2008 to 2011. Then increased in a different linear pattern from 2012 to 2015, as shown in the bar graph. And boo hiss, they didn't show the bar graph. Now, people at home can't see this, but you can, so I'll hold it up here if you don't have a book. And you see I'll try to hold it up. From 2008 to 2011, that looks like it's pretty close to linear there, okay? But then it dropped the slope some from 2012 to 2015. You know, they got more and more, so they quit building quite as many, okay? So that's what the graph looks like. Someone came in and did what they call a linear regression on those two pieces, and here's what they got as the function. S is the number of stations as a function of time measured in years now, not seconds, not minutes, not hours, but years. And it's a piecewise defined function. We had that before, right? and that would be 260.8 T minus 439. Now don't put too much emphasis on the actual numbers there, and this is good from 8 less than or equal to T less than or equal to 11. Now here's what they do with the years. They drop to 2000, okay, and they just put 8 to 11, 2008 to 2011. So each of these represents a year, but the years after 2000, okay? So this is how they shorten this, so the graph makes more sense, okay? I mean, this equation makes more sense. And then the second part is 151.2 T plus 714. And that's good for all T's between 12 and 15, 2012 to 2015. Now, I said don't worry too much about the numbers here because these are just regression numbers. They just sort of estimate. But this one is pretty important. What this is saying, in the U.S., you had about 261 E85 service stations coming into line every year, because this is the slope of that. That shows you how many service stations per year. 261. Now this out here is your y-intercept. Don't pay any attention to that. That's saying at year 2000, which would be year 0, you'd have had negative 439 service stations, which doesn't make any sense, okay? So that is just a number that fills in, but this one is significant. They're increasing at a rate of about 261 stations a year, okay? Whereas from 2012 to 15, they increased only at a rate of about 151. That's still a pretty good rate, but it's just not quite as fast as it was a while ago. This one does have a y-intercept saying, on this one, the y-intercept would have said back in 2000 there would have been 714. So again, don't pay any attention to that because that's sort of meaningless here. That's just a number to make your regression work. Okay. Now, what they want to see, where T represents the year, okay, with, say, 8 means 2008, 15 means 2015. So it's the year after 2000, okay? And S is the number of stations. Okay? That are E85 stations. Okay. Now, what they want you to do is use that function to approximate the number of stations that sold E85 each year from 2008 to 2015. Sounds like a good thing to do at home, doesn't it? Okay? I don't want to take class time with it, but I want someone to pick a year between 8 and 11. You could include either one of those. Just pick a year, any year. 2009. So tell me how many service stations, approximately, were there in 2009. What would you do? Plug it in. Plug a 9 in for T, right? Multiply by, you use this formula because you're between 9 and 11, right? Okay, that's not 9 and 11. Okay, no, you're between 8 and 11. Okay, that makes sense. So 261.8 times 9 minus 439. What do you get for year 2009? How many stations? Anyone got a calculator? Oh, y'all are doing it by hand. Oh, y'all are good. Anyone with a calculator? 1,900 what? 13 point what? 0.2? 1917.2. Okay. I wonder where that 2/10 of a service station was. That kind of doesn't make too much sense, does it? So let's just drop the 0.2, okay? About 1,917 stations. Let's see what they got for 2009. Okay. Now, how did they, or we, or somebody mess that up?
Is it 0 or 1?
Oh, that's a 0 there. You're making fun of my writing now. I can tell. Yeah. Mm-hmm.
You said 261.8.
Okay. No. Okay. I was rounding before and said that's about 261 stations a year. Okay. But when you're doing this, actually use their number. Okay. Sorry. I probably screwed you up on that one. Sorry. So what do we get again? 908. Okay. All right. And it's all approximate anyway. Okay. Okay, and this is number of stations. Okay. Now, someone pick me a number between 12 and 15. You could use 12 or 15. I don't care. 13. Oh, lucky. Okay. So, 2013, how would you approximate that to be? Just a word to the wise. Remember, calculators are permitted and allowed in the course. I'd say encouraged. When you come to take your test, bring a calculator. And one that you know. You don't want to be trying to figure out how to use it on the day of the test. So, say again? Anyone get an answer, huh? What you get? 680. That's what the book got to. I will say good for the book. Okay? All right. Got it right. Any questions on that? You can do all those if you want to. If that enhances your understanding, and knock yourself out. Okay? But you see how to use a piecewise defined function. If I threw out a year, you first figure out which year, which range it's in, and then, or domain it's in, and then use the one that corresponds to that. Make sense? All right. Then let's move on to the next topic, which is difference quotients. Have y'all ever run into these before? Yay or nay? Huh? Ever run into a difference quotient before? Okay, probably not by that name. What would difference quotient mean? What does a difference mean? What operation is implied? Subtraction. What does quotient mean? Division. Okay, have you ever subtracted and divided some things together? I bet you have. Okay, have any of you ever tried to calculate the slope of a line? What's the slope of a line? Anyone remember that? Say again? Okay, that is an equation of a line. Y is equal to mx plus b. But if you didn't know what m was, how do you calculate the slope? Say that again. y2 minus y1 over x2 minus x1. Okay? Now we call that, the y's are on the vertical axis, the x's are on the horizontal axis, so the change of y's would be your rise, and your change of x's would be the run. This is rise over run, right? That's what slope is. Right? Ringing any bells distantly in the past? Yes. Guess what this is? A difference, and a quotient. Yes, you've done different quotients before. You just didn't call them difference quotients. That's exactly what we're going to be doing. Well, they're going to disguise it, but we're still going to be doing it. Okay? One of the basic definitions in calculus, and guess what class this is? Pre-calculus algebras. That's why we're focusing on calculus. I hope that most of you will go on and take calculus. Have a feeling a lot of you won't. They never do. But if you do, you'll run into this. One of the basic definitions in calculus employs this ratio, which is, now, what did I tell you F was always?
Y.
Yes. So this is a y2 when you're at x plus h, somewhere over here, minus y1, which when you're at x. So this is a y2 minus y1, right? Where your first x was x plus, your first x was x, your second x was x plus h. Okay, so there's two different x's, and this is two different y's. And then guess what x plus h minus x is? Ooh, let's do that. X plus h minus x. X's go to 0. H. So this is a difference quotient. This is your rise, the F's on the vertical scale, and this is your run. The H is how far you went from x to x plus h. That's a rise over a run. Okay? You're used to this, aren't you? Okay? Now, this is true as long as h is not 0. Okay? And that's where calculus comes into play. Because good old Isaac Newton was trying to do this and going from doing average difference ratios to instantaneous. And somebody before him had come up with the concept of a limit. And as h gets closer and closer to 0, does this ratio get closer and closer to something? That's what calculus will deal with. You don't have to worry with that too much. Okay. So that ratio is called a difference quotient, and that's illustrated in this example. Okay? Now, I haven't got my clock out. Watch out. Huh? Okay, we got plenty of time. Okay. All right. If this is our F, it says it is, we need to find the difference quotient of F of x plus h minus f of x, but then divided by h. So what's one of the first things we're going to have to do? Okay, plug in what? Yeah, I think you're absolutely right, but what do we plug in? Yeah, we plug the x plus h in instead of x. So f of x plus h. What would that be? We did it earlier. Okay, say again. X plus h squared minus 4 times x plus h plus 7. All right, let's do the math. What is x plus h squared? You want to remember the shortcut, or do you need to go off to the side and do the longer way? Second? Okay, you want to FOIL it? So what would you FOIL? X plus h times x plus h. That's what it means to square something. Multiply it by itself. So FOIL it, and what do you get? X squared plus xh. Second? Plus hx, which is the same thing, by the way, and then plus h squared. Well, what is hx plus hx? Plus 2hx, and then plus h squared. Okay. Okay. So, we got that done. The shorthand, anytime you square a binomial, square the first, twice the product of the two, square the last. Save yourself, because that's what you're doing. You squared the first, you added this one to that one, that's twice the product of the two, and then you squared the last. You can do this anytime, and you get a happy face for doing it, and maybe that's what you're after, but you can do it much shorter there. Okay? What's next? Second? No, here. All you did was x plus h squared. Okay. Say again? Minus 4x. You distribute the minus sign too. Minus 4h plus 7. All right. Get out of there. Okay. That's the first part. Okay. And then what we want to do here is subtract f of x from that. So if you forget this, and now we're going to do difference quotient. Okay. It's f of x plus h, which is that part, minus, now be sure to put that in parentheses. What's your f of x? X squared minus 4x plus 7. And then we're going to take all that and divide by h. What's that? Yeah, I heard something about a negative sign.
Once you distribute that negative sign to that parentheses.
Okay. You don't like it there, or it needs to be there, or what? See, that's,
You think you want it from the parentheses?
Yeah, do you want to distribute that within the parentheses?
yeah, that's our next step. You're absolutely right. Very good. Okay. You could have done it at that point, but I didn't want to confuse anybody. I would have done it at that point. So I like the way you're thinking. Okay. So this is, I just don't like writing all this down. X squared, and by the way, you try to combine like terms, but there aren't any. So it's x squared plus 2hx plus h squared minus 4x minus 4h plus 7. Now distribute the minus sign like you said, and what do you get? Minus x squared. Okay, how about the 4? Okay. Plus 4x minus 7, all divided by h. What happened to my h before? I don't know. Okay. Now we see if we can combine any like terms. Whoa, here. X squared minus x squared goes to 0. Anything else? Minus 4x plus 4x goes to 0. Ooh, plus 7 and minus 7 goes to 0. What do we have left? 2hx plus h squared minus 4h, and that's all, over h. Now, what can we do with that numerator? Factor out an h. I like that. Okay? So that would be h times, what's left in the first term? 2x plus what? Plus, no, you pulled out an h, so you just have an h left, right? Minus 4. Okay? All divided by h. And now guess what we can do with the h's? Divide them away. So what's your difference quotient? Your difference quotient is 2x plus h minus 4. Now, have any of you had any calculus before? Okay, some of you do. If you had some in high school, if you remember how we take a derivative, that would be 2x minus 4, right? Okay. That's the limit as h goes to 0, because as h goes to 0, what do you have left? 2x minus 4. Hey, that's what we're going to use it for when we get to calculus. Okay? So y'all are going to be with us in calculus, right? Yes. Okay, good deal. All right. All right. So there's your difference quotient. Let's see how the book did it. Okay? Let me erase all my scratch here. Any questions before I erase it? Okay. All right. First thing they did was figure out what f of x plus h is, and they did it almost the same way y'all did. They first plugged in x plus h everywhere they saw an x here. So x plus h squared minus 4 times x plus h plus 7 minus your f of x is x squared minus 4x plus 7, all divided by h. That's your difference quotient. Okay, now they expand this which is your x squared plus 2xh plus h squared minus 4x minus 4h plus 7 minus x squared plus 4x minus 7. Don't forget those minus signs, okay? The whole purpose of minus signs is to trip you up, you know, so watch out for them. They're there to catch you, okay? It's divided by h, okay? So, here we see we can eliminate x squareds, 4x's, and 7. They all go out, leaving you just 2xh plus h squared minus 4h divided by h. But in that numerator, you can factor out an h, which they did, h times 2x plus h minus 4, then divide out the h's, so your difference equation is 2x plus h minus 4, as long as h is not 0. Remember, that was carried here. But if you let h get closer and closer and closer to 0, this gets less and less and less. Your limit there would be 2x minus 4. That's what we'll be doing in calculus. All right, that's example 11. Now, how much time do we have? 4 minutes? Okay, I think we can do this. There's nothing to do here. Yes, okay, let's use every second. All right, summary of function terminology. A function is a relationship between two variables such that to each variable of value of the independent variable, there corresponds exactly one and only one variable of the value of the dependent variable. That's what a function is. Function notation, remember that. Y is equal to f of x. If you remember that, you got it right, pretty much. F is the name of the function, y is the dependent variable, x is the independent variable, f of x is the value of the function when you plug in an x. Domain of the function is a set of all the inputs, all the values that you can put in for the independent variable, in this case x, for which the function is defined. So you have to pay attention to that and make sure there's no places where it's not defined. If x is in the domain of f, then f is said to be defined at x. If x is not in the domain of f, then f is, guess what, said to be undefined at x. And that would be any, what are the two places you watch out for? If you have x's in the denominators, you got to make sure none of the x's will make that denominator 0. Okay? The other place you watch out for is in square roots or any even root. Okay? The range of the function is a set of all the values or outputs assumed by the dependent variable, that is, the function values. In the implied domains, f is defined by an algebraic expression and the domain is not specified, then the implied domain consists. You always assume all real numbers unless you have some that it would not be defined. For instance, x is in the denominators, that would make the denominator go to 0, or x is under a square root, which would make that go negative. You have to exclude those. All right. That finishes 1.4. Okay. So where we'll start next time, since people are getting ready to leave, it looks like, we'll start with the vocabulary at the top of page 44, but homework exercises would be any of the odds, 5 or 7. They're both a Calc Chat. 7's a Calc View. Do number 9 is a Calc Chat. Odds 11 through 17, they're all at Calc Chat. 11's a Calc View. Any of the odds 19 to 29, they're all at Calc Chat. 21's a Calc View. Either 31 or 33, they're both at Calc Chat. Any of the odds 35 to 41, they're all at Calc Chat. 37's a Calc View. 43 or 45, they're both at Calc Chat. 43's a Calc View. Any of the odds 47 to 55, they're all at Calc Chat. 49's a Calc View. These are new ones, I think, here. Number 57 is a word problem. 59 is a geometry. 61 is path of a ball. So I would say do any of the odds 57 through through 71. Okay? Pick the ones that make the most sense to you. Seemed like they would be the most interest to you. Okay? These begin on page 44 and so far, and they go through 48. Okay? And on page 48, do any of the odds 73 to 79, they're all at Calc Chat. 75 should be at Calc View. Do either 81 or 83, they're both at Calc Chat. And then you can explore doing the true false 85 or 87. There should be at Calc Chat. I don't really care for 89 that much because it's wrong, but they're trying to help you figure out why it's wrong. You can think about doing 91. It should be at Calc Chat. Same thing with 93. Okay? Pick up and go. Yeah. But you don't have to do that one if you don't want to.
Turn it all together?
I'm sorry?
Want to turn it all together?
No. They're strictly for your practice.
Oh, just
Yeah. Okay, and if you have questions, please see me. Okay, I think we just destroyed my plug-in here.
To get the online book with Cengage, you have to have the access code that you're going to put on Blackboard tonight, right?
I'm going to try to, but she said she was able to access hers.
I can get the online book from Cengage.
Unlimited?
Yes.
Okay, you should go in there, go to your dashboard. Yeah. Well, no, you need to go to their home page first. You need to go to their web.
Okay, yes, sir.
I'm telling you about my science class thing. So for September 19th,
Right.
they're doing a Phi Theta Kappa introduction ceremony. It's gonna be at 1 o'clock.
Right.
So I'm not gonna be at class that day.
Oh, what a shame. Okay.
So I'm just like letting you know ahead
Yeah,
of time.
okay. Appreciate it.
Thank you.
All righty. Yes, ma'am.